Hello and welcome to Engineer's Mindset. So in this video, I'm going to be showing you how to find the derivative of cos x from first principle. Alright, so let's get straight to it. We are given that y is equal to cos x and we are asked to find the y dx from first principle. Now the first thing you do is you increase y by changing y. That will cause a corresponding increase in x by a change in x. So I have y plus change in y. If this happens, this simply means I will have cos, then I will increase x by what? Change in x, and you have this. Now, at this point, you simply recall your trigonometric identity. Recall that when you had cos A plus B from trig identity, we said this is simply cos A cos B minus sine A sine B. From trig identity, we have this. So this simply implies that if I have cos x plus change in x, this is going to be equal to cos x cos change in x minus sine x sine change in x. So which means in place of cos x plus change in x, I will simply replace with this. So this equation becomes y plus change in y equal to, in place of cos x plus change in x, I simply have cos x cos change in x minus sine x sine change in x. So you have this. Now, I want to find the y all over the x. At this point, I need my change in y to be here. So which means I will simply what? Send y over to this side of the equation. Therefore, change in y is going to be equal to, I have cos x cos change in x minus sine x sine change in x. Now, if positive y plus and equal to sine, it becomes negative y. So you have this. But not forgetting from the question, we said y is equal to cos x. So which means in place of this y, simply plug in the value as cos x. Therefore, this equation becomes change in y equals cos x cos change in x minus sine x sine change in x minus, in place of y, it becomes minus cos x. So minus cos x. Now let's try and rearrange a little bit. I have cos x here. I'm having cos x here. So let's bring them together. So I have change in y to be equal to, this becomes cos x cos change in x. So just simply rearrange, bring this over here. I have minus cos x, okay, minus, put down this. I have sine x, sine change in x. Okay, so at this point, what I will do is simply factor cos x, because cos x is common amongst these two. So simply factor cos x from this side of the equation. So change in y is now going to be equal to cos x is common into, I have cos change in x minus 1. Of course, cos x multiplies cos change in x simply gives us cos x cos change in x. Similarly, cos x multiplies minus 1 simply gives us minus cos x. So all we did here is simply what? Factor out cos x. So you put down this part of the equation, minus sine x sine change in x, and you have this. Now at this point, what you do is simply divide both sides by change in x. Divide both sides by change in x. So I have change in y all over change in x, okay? Change in y over change in x. Since I am looking for the y dx, so you simply divide both sides by change in x. This becomes equal to cos x into cos change in x minus 1 divides by change in x, okay, minus sine x sine change in x divide by change in x, and you have something like this. Now, at this point, I'm going to be using a different approach from what I used in my previous video, still on this topic. Okay, so you can do well to watch the link in my description to watch the previous video I did with a different method to see obtain the same results. What I will do at this point is simply multiply this part of the equation by the conjugate of the numerator cos change in x minus 1. So if I have cos change in x minus 1, then its conjugate becomes cos change in x plus 1. So I will multiply the top and the bottom, which is numerator and denominator of this part of the equation, by that given conjugate. Okay, so without applying the limit directly from here. So I'm going to have change in y all over change in x to be equal to, I have cos x, okay, cos x multiplying now by cos change in x minus 1 all over change in x. Now I will multiply this part of the equation by the conjugate, which is cos change in x plus 1 all over cos change in x plus 1. Now keeping in mind, cos change in x plus 1 divides cos change in x plus 1 is simply going to give us 1. And 1 multiplies everything here, still remains what? This still remains everything here. So this simply means that I am multiplying the whole of this by 1, which still keeps it or keeps the equation in order. Okay, then keep back now this second side of the equation, sine x, sine change in x. So I have minus sine x sine change in x all over change in x. Okay, so let's expand these brackets and see. I will have change in y all over change in x to be equal to, I have cos x into, so let's expand now, cos change in x multiplies cos change in x. This simply gives us cos squared change in x. Again, cos change in x multiplies plus 1. That gives us plus cos change in x. Again, minus 1 multiplies cos change in x. This gives us minus cos change in x. Again, minus 1 multiplies plus 1. That gives us minus 1. Okay, so the whole of this divides by, this becomes change in x multiplying the denominator, which is cos change in x plus 1. And I have this. Okay, not forgetting minus sine x sine change in x all over change in x. Okay, so this implies change in y all over change in x is now going to be equal to cos x into, now observe, cos x minus cos x is off, that 0. So I simply have cos squared change in x minus 1 all over my denominator here. Change in x multiplies cos change in x plus 1, and you have this, okay, minus sine x sine change in x all over change in x. Okay, so now we are going to recall another trig identity. Recall that from trig identity, cos squared change in x plus sine squared change in x is going to be equal to 1 from trig identity. So which means we can actually make cos squared change in x subject of the formula. And if you do that, you're going to have that cos squared change in x is actually equal to, it becomes 1 minus sine squared change in x. So I have 1 minus sine squared change in x. So let's plug this value into this equation in place of cos squared change in x. So I'm going to have change in y all over change in x to be equal to cos x multiplying now, in place of cos squared change in x, we put in this value 1 minus sine squared change in x, not forgetting we have minus 1 here, minus 1, okay, divide all through by change in x, multiplying now by cos change in x plus 1, okay, and you have this, okay, not forgetting minus sine x sine change in x all over change in x. All right. All right, so you observe from here, 1 minus 1 becomes completely 0. So I am going to have change in y all over change in x to be equal to cos x, now multiplied by negative sine squared change in x all over change in x multiplied by cos change in x plus 1. Okay, let's confirm that. All right, so it's in order, then minus this. So I have minus sine x, sine change in x, all over change in x. Okay, so this becomes change in y all over change in x is equal to, this is cos x into, so you know I can also write this as minus sine change in x multiply sine change in x all over change in x into cos change in x plus 1. Okay, multiplied by sine x, sine change in x all over change in x. All right, so of course, sine change in x multiply sine change in x simply gives us sine squared change in x. Now, this is what I'm going to do. Change in y over change in x is now going to equal to, this is cos x multiplied by, so I will break this equation a little bit. So I'll simply have sine change in x all over change in x multiplied by negative sine change in x all over cos change in x plus 1. Of course, this equation is still the same. Sine change in x multiplies negative sine change in x simply gives us negative sine squared change in x. Okay, whereas change in x multiplies cos change in x plus 1 also give us this. Okay, this times this gives us simply this. So the equation is mathematically correct. Now, since I splitted here as sine change in x over change in x, I'm still going to maintain that same order here. This becomes minus sine x multiplied by sine change in x all over change in x, and you have this. So we are simply bringing all the terms that contains change in x together. Okay, so it becomes sine change in x all over change in x. Now at this point, I'm going to apply my limit. The limit as change in x approaches 0, this function change in y all over change in x automatically approaches what is called dy all over dx. So this simply means that in this equation, wherever I see change in x, put in the value as 0. If that happens, then change in y over change in x automatically becomes what? Dy all over dx. So this simply implies now that dy all over the x is equal to, this becomes cos x, the limit as change in x approaches 0 of sine change in x all over change in x. All right, this multiplied by limit as change in x approaches 0 of this same part, I have negative sine change in x all over cos change in x plus 1. Okay, you have this minus sine x limit as change in x approaches 0 of sine change in x all over change in x. Now, this simply means that wherever you see change in x in this equation, simply put in the value as 0. But before you do that, observe something. I have the limit as change in x approaches 0 of sine change in x all over change in x. From L'Hopital's rule, from L'Hopital's rule, the limit as change in x approaches 0 of sine change in x all over change in x, this value is equal to 1. Now stick around in this video. I am going to show you at the end of this video how this is equal to 1. So don't be in a hurry, just stick around and enjoy the video. At the end, I will show you how the limit as change in x approaches 0 of sine change in x over change in x is equal to 1 using the L'Hopital's rule. So that simply means that in place of sine change in x over change in x, the value is equal to 1. Similarly, for sine change in f over change in x over here, the value also remains 1. So in this other side now, wherever we see change in x, simply plug in the limit as what? 0. So let's try this and see. Alright, so dy over dx is now going to be equal to, I have cos x over here. Now, the whole of this is equal to 1. So multiply by 1, multiply also by, I have here minus sign change in x. In place of change in x, put in the value as 0. So that becomes minus sign, in place of change in x, it becomes 0. So minus sign 0 all over here, I have cos change in x plus 1. That becomes cos 0 plus 1. All right. Minus sine x multiplies, of course, sine change in x over change in x. When change in x tends to 0, simply gives us 1. Okay. So this is multiplying by 1. All right. All right, so dy dx is now equal to, I have here cos x multiplies 1, then we have minus sine 0, of course, is 0. Please take note, sine 0 is 0, so minus sine 0 remains 0. So I have cos x multiply 0 all over. Now, at the denominator, I have cos 0. Cos 0 is 1. So you have 1 plus 1, because this is cos 0 plus 1. So cos 0 is 1. That becomes 1 plus 1, and that gives us 2. So this is now 0 all over 2. Okay. Then you have minus sine x multiplies 1. That simply gives us minus sine x. Now, 0 divided by 2, of course, is 0. So you have this to be equal to cos x multiplied by 0 minus sine x. Of course, cos x times 0 remains 0. So this simply implies that dy all over the x is equal to 0 minus sine x, which simply implies that dy over the x is equal to 0 minus sine x, simply gives us negative sine x, of course, and that is the value of that derivative. So when y is equal to cos x, dy dx is simply what? Negative sine x. So this is the value proven from first principle. So as said earlier, at the end of this video, I am going to show you how from L'Hopital's rule, the limit as change in x approaches 0 of sine change in x over change in x is equal to 1. So let's do it and see. Now, limit as change in x approaches 0 of sine change in x all over change in x. Now, from L'Hopital's rule, whenever you substitute the given limit into the function and you have an indeterminate expression, then L'Hopital simply says differentiate the top separately, differentiate the bottom separately. For instance, if I put in this limit as change in x approaches 0, so simply putting the value of change in x as 0 into this equation, I am going to be having sine 0 because change in x is equal to 0 all over, and then change the x here as what? 0. Now, this is going to give me sine 0 is 0 all over 0, and 0 over 0 is what is called indeterminate expression. So this is an indeterminate expression, which is something we don't want to see in limits. So if upon substitution I'm going to have an indeterminate expression, then L'Hopital rule simply states differentiate the top separately, differentiate the bottom separately, and impute the limit. So seeing now that upon direct substitution I'm having an indeterminate expression, then this is going to now be limit as change in x approaches 0. Now, if I differentiate sine change in x with respect to change in x, I'm going to have cos change in x. So simply what? Differentiating sine, and you have cos. Similarly, if I differentiate change in x with respect to change in x, that simply gives me what? 1. So which means cos change in x over 1 simply remains cos change in x. Now plug in the limit as change in x approaches 0. This becomes cos 0, because in place of change in x, we simply have it to be what? 0. Divides by 1. Now, what is cos 0? Cos 0 is simply equal to 1 all over 1, which is equal to 1. So this simply implies that the limit as change in x approaches 0 of sine change in x all over change in x is simply equal to what? 1. And that is from L'Hopital's rule. So that's how that rule or that law came about. Alright guys, so that's it on that particular question on how to differentiate cos x from first principle. In the next video, we are going to be doing how to differentiate sine x from first principle. Do well to look at the description to watch the previous video on this particular topic and see the different method I use in both of them. I will see you in the next video. Thanks and cheers.